What we have prepared for today, it's a summary of what is going to come in the 128 release from Kubernetes upstream. And together with us is Angelos, who is also part of this release team. And then he's going to make the update on what are the most important relevant functionalities happening in the release. So Angelos, when you want.
Yes, thank you, Yatan. Hi all. Let me share my screen. All right, can everyone see this? Okay. All right, welcome everyone. Yeah, just a quick introduction. My name is Angelos Kolaitis. I'm in the MicroKits team in Canonical. I'm also part of the Kubernetes release team, as Yatan said, for the past 3 cycles, and I'm currently serving as a release lead shadow for the 128 release, which is a quite interesting role and very nice experience. And that's it for the introduction. I'm not a very interesting person. Okay, let's get started. Let's give a quick overview for the release schedule of Kubernetes 128. First of all, we're currently at alpha.4. Beta 0 was scheduled for July 20th, yesterday, but there were some issues, so it's currently underway, actually. I think it's supposed to be released in a few hours' time. Then on July 25th, we have the RC0, and August 10th is the RC1. This is all basically in preparation of the GA release on August 15th, if everything goes according to schedule.
Angelo, can I make a question on the previous slide?
Yeah.
When is the code freeze for this release?
Code freeze has been in effect since last Wednesday, basically for 2 or 3 days now.
Okay, thank you.
So we are currently, yes, I should have mentioned that maybe. We are currently in code freeze. Test freeze is also right around the corner. And then it's just bug fixes and making sure that the release is at a stable level for GA. Right, so what we'll talk about in this presentation, first of all, Kubernetes new features are called enhancements, and there is a very specific process of how they are implemented, proposed, and merged into main Kubernetes branch. Right now, for the Kubernetes 128 release, we have 43 new enhancements. I think there is 1 or 2 more exceptions that are pending to be approved, so it might be a bit more before the release. Basically, the enhancements are split into alpha, beta, and stable. Alpha means disabled by default. You have to enable it manually, and the feature might contain bugs because it's basically just been introduced. Beta means that the feature has had 1 or 2 rounds of being in alpha state with bug fixes and increased support from multiple members. And finally, once a beta feature is considered stable enough, it graduates to stable. So that's what alpha, beta, and stable is about in this meeting. So again, we have 43 enhancements. We cannot talk about all of them, and there's no point. So we'll just talk a bit about some that we think are quite important. Namely, these are on the left. These are sidecar containers. There is CL for admission control. There is kubelet limiting of parallel limit spools. There is handling of non-graceful node shutdowns in kubelet, and finally, host IP status in the pods. I have also added links for the enhancements board that the release team uses to track all of the enhancements, and finally a link for the release notes, which are still currently in draft, obviously, before the final release. Okay, without further ado, let's get started with some details about the individual features. One of them is the most important, I think, for most of the community is sidecar containers. So this has been discussed for a very long time, and sidecar containers as a pattern has been known for years now. So what this feature does is basically, you know that in a pod you can have 1 container or multiple containers, and it's quite common as a pattern to have several auxiliary containers. For example, for your service mesh, for Istio, or if you have a logging forwarding to your main, like logging aggregation stack, or you might even have a side container watching for configuration and even live updating the configuration of the main application you're running. So this is finally supported. Support for that is added to core Kubernetes as an alpha. So to enable it, you have to specify this feature gate basically in all of the Kubernetes components. And then what this looks like is in your pod definition here, you can have, similar to how you defined init containers in the past, this is already supported. You can specify restart policy as always, and that tells Kubernetes that this is in fact a sidecar container. And Kubernetes will do very nice things with how it manages its lifecycle. As one example, imagine the case where you want the sidecar container to forward your pod logs into something like Loki or whatever. In the past, precisely because there was no guarantees between the lifecycle, it could be possible that the container where the logging was forwarded would terminate before the main container. So you would lose logs, and very important logs for that matter. So this is now much better supported in Kubernetes. It's important to note that this feature has been in development for quite a long time and has been discussed quite a lot. So it's interesting to see that it's finally getting merged in alpha. Next is CL for admission control, which is now in beta. I see there is a question on the chat. We can have a Q&A afterwards, but yeah. So for CL for admission control, the important thing for that is that in the past, Kubernetes has lots of different types of resources, and it is quite common for operators or for administrators to add validation controls on them, so you cannot really create any resource that you want. In the past, this meant having to write a separate service that worked as a webhook and then deploy it on the cluster and specify very complex validating webhook configuration hooks. This can now be done with a much simpler way for most basic things using CEL. Basically, instead of having to write a separate web service and doing all this dance, you can just specify things like this YAML describes here, which this is just an example from the KEP, which basically means that so when you have a request to create a pod, verify that this pod actually has a volumes which has an NFS volume defined. Now, this obviously is just one example. You can basically do whatever you want because object has all of the fields of the object that you're trying to create, update, delete, or any other action. For example, you might be able to specify policies around, I cannot create any pods or deployments without a specified set of labels. This might be good for multi-tenant clusters and ensuring that all resources follow a specific policy, and many more examples. And also, a telling example is this one, where instead of just the object that is being edited, you can also refer to the user that is performing the request. For example, this one here says this complex basically thing means ignore all the requests that come from a kubelet. And this gives you a very strong way, a very strong language to define these sort of rules for validation. This is also quite nice. And again, to enable this feature, you have to specify the feature gate, this one to true in the API server. Next, kubelet limit of parallel image pools. So kubelet has, in the past, in the very old times, kubelet would only support pulling one image at a time, which could cause a cluster to delay starting your workloads if you had to pull in a lot of images. So kubelet added support for parallel image pools. This means that it doesn't have to wait for an image pool to complete to start a new one. But then imagine if you try to start some pods and you have to pull in hundreds or thousands of images, then this could cause an issue where you basically block the whole network or cause latency or something else. So with this feature, you can basically go ahead and say, kubelet, okay, you can pull images in parallel, but not more than 10 at a time, which is quite cool and can be quite helpful in a lot of scenarios. Next is non-graceful node shutdown. This has graduated to stable now. Not much to say here other than if your kubelet goes away, if your kubelet goes down in a non-nice way, let's say if you have power outage or something else, you can be sure that kubelet will be able to start and work without issues. The impact is you can now sleep during the weekends without any problems, and you don't have to do anything from the configuration side. And finally, one more feature that is interesting and we quite like it actually is the status host IP is filled for pods, which is now in alpha. Now, what this means, in the past, it has been very troubling to access the host from a pod. So a pod is running in its own separate network namespace, which means localhost is not the host that it's running on, but rather the network namespace of the pod itself. And if you try to access something on the node where the pod is running, this can be very troubling. With this feature, you can add an environment like this. For example, my host IP is and just get the status .host IPs. This is the downstream API from Kubernetes. So you don't have to do anything to get this. And basically, when the pod is running, you get a value of all the IP addresses of the host where this pod has been scheduled. To enable this, again, you need to add this feature gate for the host IPs to Kube API server in kubelet. And that's it. As for impact and application, this has quite a lot of cases. One thing is the CNIs. So quite a lot of CNIs require the host IPs to do their basic configuration for the most part. But this is also quite interesting, especially for microgates. So if you are just running microgates and also have some workloads on the same host, you might be able to use this to automatically get access to the database running on the host or any other application that's running outside of Kubernetes without too much trouble. So that's about it for the feature highlights. Can we try this? Yes, you can, of course. You can just use microgates. Basically, in microgates, we have channels for specific versions. There is a channel for 127, which is currently out, 126, and all the versions back. And we also have the edge channel where basically bleeding edge development builds go out. And we actually have one called 128/edge, which gets new upstream releases every 4/128 within 24 hours after the upstream release. It's basically just time for us to validate the release and put it out there for you to enjoy. And this is all. This is a list of links that you can follow up on. This is the GitHub repository for microgates. This is the main website. You can find us on the Kubernetes Slack on the microgates channel, where we're quite active with requests or discussions or anything you want to talk about. We're quite friendly. If you have any issues, please report them to GitHub. This is the recurring meeting that we have past community hours. And finally, a small introduction to the upcoming sessions. For microgates 128, we're adding CIS conformance. We're adding support for dual stack and IPv6 natively. And finally, we are going to be integrating with Ceph clusters to consume Ceph clusters for storage easily. And there's a quite neat feature with a feature of Microsoft there for even better integration. And you can also see the whole calendar in the meetup group. That is all. Thank you. I see there were some questions, and we can now talk about anything you want.
There are a couple of questions. Do you want me to read it, Francisco, or do you prefer to talk yourself to Angelos?
I can ask. When you were mentioning the admission control policies, is that something that could replace, for example, Kyverno for policies, or is it much smaller feature set?
So I'm not familiar with all of the specific features of Kyverno. In my understanding, it's if you're using Kyverno for something very simple, this could be maybe an easier way to do this sort of thing, especially since it's like part of main Kubernetes instead of an added feature. But I don't expect that this is like 100% replacement for Kyverno.
Okay.
Yeah.
Bala, same thing. Do you want to make the question yourself or?
Oh, yeah. So what is the default value set for this parallel image pool? Is it 10 or?
That's an interesting question. So I think it's not set by default, which means that if you specify the kubelet that yes, you can pull matches in parallel, it will basically just say, okay, no limits, I think. But the cap has all the details if you want to have a look at it.
Okay. So on each node, it has to be set then. So what if one node will have this parallel image pool and other node doesn't have it? How is it going to behave?
Yeah, so this is basically per node configuration. The worst thing that might happen is that one node will pull images faster or might meet more rate limits than the others.
Okay, so that means we need to calculate the bandwidth on each node or the workloads, what it's having it based on that, you need to configure it.
Yeah, exactly. It's basically a per node configuration.
Yeah.
All right. Any other question or?
Also, I just like asking this always. Any other question, even unrelated to the presentation? Anything anyone would like to talk about?
Let me try to stop the recording then.
Yeah.
Okay.